Hi, today we're going to look at optimizing a function of several variables using the d-test. Our application happens to involve a company manufacturing two different models of MP3 players, and they are looking to come up with the production level that will maximize the revenue. So let's quickly kind of look at the d-test here. Now, if you haven't seen the d-test before, you may want to freeze it so you can read through it a little bit more, but the d-test is going to require you to get the second partial derivatives to get this value of d here. And then once you have this value of d, you can use that to identify whether the critical point of your function is a minimum, a maximum, a saddle point, or sometimes you might get no information. But our goal really today is hopefully that this number 2 is going to come true, because we're looking for a maximum. So what we're hoping is when we find the value of d, we get a positive. And then if that value of d is positive and our second derivative of our function is also negative, then that means we're going to have a maximum at our critical point. And that's our goal today. So that's what we're looking for. Okay, so back to our problem here. So we have this company. It's got two different kinds of MP3 models. So first we're going to find our marginal revenue equations, and those are just the derivative of the revenue. So we start with our R of x, and so that's taking the derivative of the revenue function with respect to x. So derivative of 48x would be 48. The derivative of 96y is 0. The derivative of minus x squared will be minus 2x. The derivative of 9y squared is 0. And the derivative of minus 2xy is minus 2y. Okay, so there's our marginal revenue function with respect to x. Now, with respect to y, we go back to that original revenue function and do the derivative, but again, focusing on y as being the variable and treating x like a constant. So therefore, the derivative of 48x will be 0. The derivative of 96y is 96. The derivative of the x squared is 0. The derivative of negative 9y squared is negative 18y. And last, the derivative of minus 2xy will be minus 2x. Okay, so these are our partial derivatives. If we set those equal to 0, we can find the critical point. So the critical point or points will be where these first derivatives are equal to 0. So let me do that. Take our first derivatives here, set them equal to 0. Now this other one, I'm going to sort of rearrange the order. I'm going to put it in order so that the like terms kind of line up here. That'll help me. So I set these both equal to 0, and then what I have is I have a system of equations that I need to solve so that I can solve for x and y. I think the easiest way for this one would be to do elimination, and I think I could make these x terms eliminate if I were to multiply, well, either equation, but I'll choose to multiply the second equation by a negative 1, and therefore my goal will be to make these x terms cancel out. Okay, so here's my new equations then. I'm going to end up here, the first equation just staying the same. So we have 48 minus 2x minus 2y is 0. The second equation, the signs are going to change. I'm going to have a negative 96, a plus 2x, a plus 18y is 0. And then everything's lined up. I'm going to add these equations. And when I do that, these x terms will cancel out. And therefore, I'm going to end up with a negative 48. Adding the y terms, I get a 16y equals 0. And then I'm going to solve that. Let me throw the 48 to the other side. So 16y equals 48. Dividing by 16, I get y equals 3. Okay, and then using this y equals 3, I'm going to come back over here. I'm going to find the x, because remember the critical point is an x and a y. So I can plug the y into either equation. I'll just plug it in the top equation and then solve for the x. So I'm going to put y is 3 in here and solve for x. Combining my like terms here, I have a 48 minus 6. So I'm going to have a 42 minus 2x is 0. And then I'm going to have a 2x is 48, and therefore x is going to be 21. Okay, so I have a critical point, and this critical point is the ordered pair 21, 3. All right, so it's this critical point that I'm going to work on and try to figure out, is this critical point a max or a min, or possibly neither. Hopefully that won't happen. So I'm going to use the d-test. All right, so the d-test is going to require the second derivatives, the second partial derivatives. So I need to get r of xx, r of yy, and the mixed r of xy. All right, so let me get those first. So r of xx is when you just take your first derivative of x and do the derivative again with respect to x. And so with that first derivative, there's only one term that has an x in it, and that's the minus 2x. So the derivative is going to be just minus 2. The r of y is going to be taking that first derivative with respect to y and doing the derivative again with respect to y. And again, that first derivative only has one term that has a y in it. That's the minus 18y. So the derivative of minus 18y is minus 18. Now my xy, that seems to be the most confusing one. So you're going to take your derivative with respect to x, your first derivative with respect to x, and then do the derivative of y. So that derivative with respect to x, the first derivative, has a single term in it that has a y. It's a minus 2y, and the derivative of that is minus 2. All right, so this is what I need. So now remember, the value of d is found by taking your second derivative with respect to x at your critical point, timesing that by your second derivative with respect to y at your critical point, subtracting your derivative of x and then y at the critical point, but this is the crazy part, squared. Okay, so the value of d for us, this right here is going to be negative 2. I don't even need to plug in 21.3 because there's no place to plug it in. It's just always negative 2. This one right here is negative 18 minus, and then this value here, again, I don't need to plug the critical point in. Sometimes you do, but in this case, this value is just always negative 2, and then I have squared. All right, so my value of d, when I work this out, negative 2 times negative 18 is 36. Take away a 4 is 32. All right, so this is good news. So since, remember that d-test, since my d has come out to be a positive, that's good. That means I have a max or a min. Now what I need to look at is this value here, this r of xx. And since this value has come out to be a negative, that's perfect. That's exactly, remember back over on that d-test what I highlighted. I needed that d to be positive and the second derivative of x to be negative. Then what that guarantees then is, then our critical point, this point 21.3, is a relative maximum. Great. Okay, so that 21.3 is the production level. That's going to give our revenue a maximum. So I pretty much just have to word this. And going back and looking at the original problem, you'll notice that it said that x was in millions and y is in millions. So when I write this answer out, be sure to include that. So here goes. The production level that will maximize profit. Oh, I'm sorry, maximize revenue. So we got to remember what we're dealing with here. Revenue is 21 million of, and really they just sort of labeled them the first type. So let's see, of the first model, and let's see, 3 million of the second model MP3 player. Let's see if that makes sense here. The production level that will maximize revenue is 21 million of the first model and 3 million of the second model. Okay, perfect. So now they didn't ask it, but lots of times it does get asked, and that would be, well, what is the maximum profit? Okay, now that's easy to find out since we've done all this work. We might as well answer this. So what is the, oh gosh, and I said profit again. What is the max revenue? Sorry. So to do that, we just need to take our critical point and plug it into the revenue function, the original function that was given to us for the revenue. So we just plug 21.3 back in the revenue function. And again, it's going to take a calculator to run all that through. Let me scroll back up here, just remind you of the original revenue function. That's this guy back here. Right? This is our revenue function. That's the function that's going to tell us the revenue for any value of x and y. So that's where we're going to plug in our 21 and 3. Okay, so if you plug 21 and 3 back in that original revenue function, you're going to get the value of 648. Now remember, this is also in millions because the quantity is in millions. And remember, revenue is quantity times price. So I'm going to word this answer here. We have our max revenue is I'm going to put dollars here, 648 million. And that just gives you a little extra information. It wasn't asked for, but might as well get it. Okay, well, I hope this has been helpful for you. Good luck.